make people who will join later, they will be able to watch the recording. And I'm really happy then to start to kick off the next session of the network seminar, which is today. It's in a very particular context of the city-oriented analysis, and the message which I wanted to kind of convey with this seminar is that actually it's very important to work together, right? To work not just with researchers in your field, but go beyond. And Talia Kaufmann, when I learned about her research from Luis Natera, I was really happy because I was actually searching for someone who would be talking more about city in the context of city interaction. So thanks so much for your time, and the floor is yours.
Thanks, Leo. So hi, everyone. I'm Talia. Just a little bit briefly about myself. I'm trained as an architect, also a city planner in my training, and right now I would say a fully fledged network scientist or data scientist that is working with data on cities, try to understand patterns that are consistent across cities and use them in order to develop new metrics and indicators that will help us plan cities better. And even before I start, what is better is a really complicated question. I guess I will we'll talk about it in more detail in a bit, but the paradigm that I think about when I think about cities is what makes people well-being. I don't know, better in a way is kind of the goal. So it's not better in terms of what is a better city or what is a less better city. It's more of the experience that, or the service that a city provides its residents. And the thought here, because I'm trained as an architect, is to come up with a better system. And that I can say for sure, a better system than architecture and city planning to do this. And that is because my experience in the training that I got as an architect taught me that design is basically not the only tool that you can use in order to think about how cities should manage themselves, and there's better ways. And basically that's kind of my goal. That's what I'm trying to aim at here. So let's start. So as I kind of stated, this is my view. It's not like the literature's view, but that's my view that land use planning decisions are not based on data. There's no metrics for spatial distribution of amenities. And I say that from my experience. I worked as a city planner for the city of Tel Aviv for a couple of years before my training, before my academic training. And I also consulted to the OECD and the European Commission, and the experience is kind of the same everywhere you go. Designers or city planners make decisions every day on how to locate amenities or in resources in general all over cities, and they don't do it based on how they evaluate or measure what actually exists. They do it based on their thoughts or their intuition a lot of the times, and sometimes or most of the time is what the developer says that is more economically beneficial for them, where they can earn more money on that land. And that is how land use decisions are basically made every day. Like we can add more floors to this building or build a park there or build a hospital there is because we have land or we have the air rights, or we can enable people to come there more, but not in terms of like what people actually need there. So the goal of my work is to think about how we collect enough data and measure cities in an objective, as objectively as possible, in order to enable interventions that are data-driven, that we know what is actually needed for the people that are there and the people that will come as we develop more. So what is land use planning? Some of you are acquainted if you're architects or city planners, but the basic, a lot of people don't know. So usually land use planning deals with two major questions. One is the quantities of the different amenities that we have in the cities, how many housing units we need, how many commercial space we need, open space, etc. And if we have some models for that in the literature, the second question that comes about is how do we spatially distribute them across neighborhoods and in combination with each other? And this, we have a lot of theories, like a ton of theories and tons of books that has been written, but nothing that hasn't been implemented actually in data-driven work every day in cities and in governments everywhere. And that's the question, the basic question that I'm tackling. And I mentioned this in the beginning, but I want to expand this a little bit. When I say, or when I think about what is better, there's no such thing as better. So let me just state here, a lot of people here, I think, are network scientists or deal with networks, and we all know that networks are complex. And cities have been, or planning problems have been defined as NP-complete problems back in the 80s when we just started dealing with GIS, and it was very, very clear that planning problems have a numerous number of possible solutions. And as Rittel and Weber said basically in the 70s, that there is nothing like the undisputable about public good. There's no objective definition of equity when it comes to cities. And this is important for me to say, because I show a lot of metrics that do evaluate and judge, but it does not mean that I say that this city is better than the other. It is just showing a phenomena and measuring in a way. I have my own bias. I'm a human, like every human being on earth. But my preferences for a city or for a good city does not reflect the professional opinion that I have, and then doesn't even project or present a lot of the ideas that people have about good cities and what is good urbanism for them. This is subjective, and when we think about what is a complex problem in cities, let me kind of give an example. If we want to put more resources and make a road better, for example, if we make it wider, there's more room for cars, there's less room for people, right? Less room for biking. That's just really, really simple to think about the different parameters that we're optimizing for. But basically every urban problem that we have is as complex as this and does not have one possible solution. It has like multiple, sometimes it's millions. So that's kind of like a strong statement that I'm making in advance of every kind of other statement that I'm going to give as I continue with my talk. So why do I deal with metrics and why do I think about objective measures? I think what is important in the act of measuring is a way that has to have a consistent way to measure across. Okay, so if we think about cities as they developed in the last 100 years, there's no one way that people could have objectively put something like, I don't even know how to say this, New York, maybe in Paris and London on one scale with numbers. It wasn't that possible because the data wasn't there. And then every indicator that we have is not really objective, not really based on data. And the work that I'm going to present to you is a search for this kind of objective metric to be able to benchmark urban performance, one across another, one city versus another city, one neighborhood versus another neighborhood, and kind of think about objective ways to observe urban phenomena in a consistent way. The way that I see city planning in the long term is something like a Lego game, basically, or SimCity, if a lot of you played. And these kind of things have two basic components. One is that we have the building blocks of the Lego or the SimCity. What are the units that we're playing with? And then what are the game rules? How do we construct or constrain the possibility of all the possible solutions to build a city? And that's basically the game here. How do we constrain the endless possibilities of putting a park next to a school, a restaurant next to a housing unit, and so on. So the three questions that I'm gonna tackle here are the three questions that we have in land use planning, basically. The first is the population thresholds. How many building blocks we need, like in a Lego game, like in SimCity. How many banks do we need, parks, restaurants, etc. in a city? And can we find a consistent way to kind of predict those? How do we distribute those amenities or building blocks across the city between different neighborhoods? And then how do we co-locate them in relation to each other? Okay. And I'm going to show three papers that I'm working on right now. One is more in the final stages, two in kind of work. The first is the scaling of urban amenities, which will discuss that question of how many building blocks. The second is a work that I did with the OECD about measuring accessibility to services across cities, and tackles that second question. And the third paper is the modeling amenity consumption patterns using mobility data. This is a new paper that I'm now working with that talks about the co-location of amenities based on data again. So moving on to the first one. So a lot of people on this are supposed to know that work, I believe, from 2007 that talks about scaling. And I find that cities across America, the 50 largest cities in America, show the same scaling relations with population when it comes to amenities. So on the left, you see the total number of amenities. And I should specify that the data I'm working with here is data from Google Maps. Okay, so the Maps API or the Places API is everything that you find on Maps when you use the app, or everything that you have on Waze, and every kind of data that they have. And I'll talk more about the quality of this data as I move to the second question, the second paper, but just specifically, this is very fine-grained resolution data. So it has everything from a store to a bakery to a restaurant to a takeout place and so forth. I basically count the number of amenities per city in the largest 50 cities in the US. I find a really, really high and nice correlation between the total number of amenities and the total population. And this types of fitting is consistent also when I break down this total, if I look at the specific categories. So what you see in the middle is universities, on the right is takeaway places. And the nice thing that we found, which is not really important for us, but important, I think, to the general science community, is that things that come in a very early stage of urban development, things that are essential, I can say hospitals or parks or banks and so on, show a sublinear scaling. So there's an economy of scale here. People share resources and the city gets bigger. There's less and less of these amenities. Whereas things that are more, I would say, luxurious come on in later stages of development, like stores and all the niche that they have in restaurants, etc., beauty salons, and those show superlinear scaling. And that's just a nice phenomena. But I'm interested in this because of this trend that I'm seeing, that trend, and that allows me to look at the error, like that line, or the distance from that line, and kind of plot the cities based in comparison. So what?
Yes.
Okay, so we were discussing San Francisco and how it compares to Boston when we look at these deviations from the fit line. So the commercial activity and the service community, the service amenities in San Francisco is much larger in compared to the average. And it becomes really interesting as you play along with multiple cities and look at the picture. Washington is again really, really strong or somewhat strong in public facilities, but much less when it comes to the commercial and services. This is a picture of LA. And again, as I said, being over the line doesn't mean that you're better off. This is a picture of Detroit. And basically what it shows is that Detroit has more amenities than population, and this is consistent with population loss or the shrinking city effect that we see so strongly in Detroit. And I'm interested in this in order to kind of think about how cities can plan better. So if we take the case of Boston and LA, Boston is the fourth in the nation when it comes in the US, sorry, when it comes to performance in open spaces. And LA is very much lacking in terms of open spaces. If LA says that it wants to create a new plan, a master plan for parks, and kind of ask the questions of, if we want to become Boston, or if we're targeting Boston, how does it look like when it comes to numbers? So right now, LA has less than 2,000 parks. And this is really important to say in this aspect, that these are numbers. These are points, singular points, which are the lat longs that I get from Google Maps. So of course, it just shows quantity. It doesn't show the square footage or the square meters of a park or any kind of amenity. This is easily fixed with overlaying with OSM data and thinking about the building footprint. Pretty sure that it will be consistent when I do that as well, but it's really an important note to specify. So as I said, right now, LA has less than 2,000 parks. If it just wants to go to the average, to get to the average performance of what a city should look like without any intervention, it's lacking almost 1,200 parks. And if it wants to go to this really high level of Boston and has much more parks than the expected level, it needs to add even more, like almost 3,500 parks. So all in all, almost 5,000 parks. Just gives you a ballpark of understanding it when a city kind of thinks about master planning and planning and where are resources needed, gives you a ballpark of where you are. So this is one, as I mentioned, as I started, this is just think about how many building blocks we need, but also we need to think about where to put them. So this is a picture of the spatial distribution of restaurants by census tracts in San Francisco and in Houston. As you can see really clearly from the picture, in San Francisco, there's much more areas, or this is like the functional urban area. So this is the bigger area or the metro area around San Francisco. So of course, it includes Berkeley and other places, not only the city itself. And it shows that there's more census tracts that have restaurants versus Houston, it's mostly in the city center that you have the, I guess, the chance of running into a restaurant if you walk by, but if you're in the suburban areas, you would have a much lower chance of running into a restaurant. And we look at this, we found when looking at this, we didn't find a correlation that is one-to-one when we looked at this picture, meaning the one-to-one of like how many people live here and how many amenities they have, but we did find a really interesting correlation between the distribution of the density of amenities. So what you see here on the left is the distribution of the density of restaurants in 5 cities in the US. And you see an exponential decay, basically. And what does it basically describes what I said earlier, which is if you walk in a city like San Francisco, Boston, for example, you have a higher chances in more census tracts to come across a restaurant, whereas in places like Houston or LA, you have a much lower rate of running into a restaurant, which means that you have a couple census tracts with a lot of restaurants, and then the majority of them that have almost none. And basically what we do here is we show that there's a correlation between the distribution of people and distribution of amenities. This is what you see here on the right. On the bottom is ATMs, and on the top is just all amenities. And we find this very nice correlation again. And we use this again to look at the idea of that city. And what you see on the left is Boston, on the right is LA. At the bottom level is the spatial distribution, this kind of ID. And what we find is basically cities that are more walkable and are more dense have basically under representation. Like their point is, yes.
There is a question from Paula, I think also, if our parks counted in units or SQM?
In units, I think I said that just before, yeah. So it's units, it's points. Yeah. Yeah. I think I'm gonna move on to the second paper because I think we're kind of running out of time and I wanna show you a little bit more. That was a good break. And of course, continue to barge in on me to ask questions if you want. So the second project that I'm gonna show you is a collaboration that I had with the OECD that is still kind of going on to measure accessibility, a framework to measure accessibility to services across cities. And here we use data, three layers of data, basically. The first one is OpenStreetMap. This is Paris. As you can see here, it's not the full, it's not all the road paths, but it's the most of it. Overlaying it is the global human settlement layer. And this is a layer that comes from aerial views that is using machine learning is translated with census data to look at a grid unified distribution of people all around the world, which is important for this kind of work. And the third is Google Places, as I mentioned, that has 96 unique categories and is globally consistent and very unique in its fullness and completeness. And that's what I mentioned
Google
before.
Places, you mean Google mapped amenities or?
Yes. Yeah. Okay. So this is everything that you have in Google Maps, basically. Okay. There's a Places API that they have, and this is what I work with. So when I worked with the OECD, they were very interested in thinking of, does this data set that is new and kind of open, but not conservative, it doesn't come from governments, how can we rely on this? How can we say that it's complete? How can we verify this? So we actually did a manual verification of this data, just because it was really, really important for the people working there. And we took a sample size of 1,000 points distributed across different census tracts in Paris and around that form a variety of income groups. And we found that basically, all in all, from all the street-facing businesses, around 80% of the Google POI data can be verified. Only 6%, about 6% to 6 to 8%, I think, is new data sources, new data points, and those 20% points that are falsified are similar to the new ones, which is the businesses that show a lot of turnover, businesses that close and open very frequently, like restaurants and stores, and they usually change, one changes another. So that change is not that important when we think about the units of the different amenities. So what we measure here is a couple of indicators, and I'll move kind of quickly across them. So we start with these points, which are from the global settlement settlement layer. We take the centroids of each of these grid cells, which represents a number of people that live in square kilometer or 250 meter square. And we calculate on the grid in walking distance, in exact walking distance, not an approximation, what is the closest restaurant, the closest park, the closest bank, and so on. And we look at the distributions of the different cities. So this is not all the cities that we have. I looked at all the cities in France here, and here I'm showing a subset of this. So you see small, medium, and large cities here, and these are weighted walking duration to restaurants in French cities. And again, this is the French FUAs, the functional urban areas. So these are really, really large areas. And as you can see, there's somewhat consistency in this distribution of the weighted walking duration, the time that one needs to walk to the closest restaurant. That is somewhere around 5 to 10 minutes. And in the smaller cities, the distribution is much more kind of long-tailed. The differences start to show as we move across different amenities, and this is parks. If the situation in Paris is that the median walking duration is 10 minutes to a park, in smaller cities in France that I don't even know how to pronounce their name correctly, like La Havre or La Rochelle, the weighted walking duration is much longer. And that is a lot that has to do with the fact that these are cities that are very close to nature and people go out to kind of reserves. And also they live in semi-detached houses and not in cities like in Paris and Lyon, and they don't really need those parks. They have their backyard. With this, I want to show you something very quickly here. I built a really nice data visualization tool just to show some of these results. And this is Boston. So not France, but I did it for Boston, for the US, for Paris, and for the US, for France, and for Israel. And I'll show you everything in a second. Yes.
And just a question. So I don't know where is Martigues, but it seems to be so kind of different. I mean, it's clustered with Beauvais, but so you did you look at the reason why it is actually so different from others?
Why the distribution looks like this?
Yeah, because maybe history of the city is like this, or
it has to do with a lot of things, but because the focus of this work here is to look at just the distributions and look at a way to kind of measure this, I didn't look into the parameters that deeply, and it's something that is still needed to do. But the framework, the kind of thought is, what is an indicator? What is a good indicator? Not about the things that kind of motivate this. That's why I don't have a good answer for this, but maybe some of you know. Sure that it has to do with something about the city itself. Just quickly going back to that data visualization pilot that I had on Boston, just to show what can be done with these kind of numbers of what is the closest amenity. So what you see here is, again, all the neighborhoods in Boston. When you overlay, you can see just the number of people that live in that grid cell and the average walking distance here to an ATM. I made it so that it's really, yes.
I don't think if all of them are seeing the screen, but I'm just seeing the plots that you have, not the visualization.
Interesting. So if I stop sharing my screen and then I start sharing again. What happens now?
It's starting.
So it's loading?
Yeah.
That's what you're seeing?
It is on black. I don't see anything. I don't know if the rest see.
Interesting. You, do you see? No, I see most of you nodding your heads.
No, we did not see, but you were sharing the plots indeed for France, and that was the last one.
Yeah. You see this?
It says double click to enter full screen mode.
Yeah, but you're the.
Interesting.
Yeah, I don't remember if you changed anything.
No, I just wanted to show I wanted to show a data visualization tool that I built, but for some reason it's not showing up. Do you still see the presentation?
No.
No.
Sometimes it's
just to continue with this, basically what we did after looking at the closest the indicator of the diversity of opportunities within 15 minutes of see here is access to restaurants, and there's 4 layers here. In purple you see the percentage of people that do not have walking access. Number here is pretty much around 25% in the entire French urban population that cannot walk to a restaurant, whereas the same number of even more have more than 5 restaurants in walking distance. And this is actually a good kind of evaluation to see what is the spatial distribution of the inequality in access. And the picture becomes kind of different as we move between amenities. So this is the case with supermarkets, and there's much more people that are disconnected or cannot walk to a supermarket in French cities. Of course, Paris is here almost always on the right because the majority of people that live in the most urban area or the most dense urban area in Paris have a very good walking access to a lot of amenities, whereas in the smaller cities, like Martinique is always on the left here. And this is the case for parks. Again, what I explained before, there's a lot of people that don't actually need walking distance to a park if they live in semi-detached houses, but more than 50% of the urban French population cannot walk to a park within 15 minutes. And again, as I mentioned before, the nice thing about this framework that is consistent and can be done everywhere in the world, basically where data is good. And what I'm showing here is a subset of cities from Israel, from France and US that I just had the opportunity of doing that for. I plan to increase this for basically everywhere where data is good with Google. But the case here with access to supermarkets, you see a very kind of big shift between Israel and France that has very dense walkable cities versus US that you have cities that are very, very sprawled, like Nashville, in this case, San Diego and Houston, that has a very nice amount of people that cannot actually walk to a supermarket, which is something that is really significant. And this is a case of parks, and here the differences are huge. And this is something that we very much know about the US, that access to open spaces is very scarce in US cities, and in most of them, about 50% of the population or more cannot walk to a park. And just to end, I want to show you something that I started working on recently, which is the modeling of amenity consumption patterns using mobility data. So I'm using safe graph data. I don't know if some of you have heard of them. POI data that is very accurate in showing how many people visited in a specific POI and how much time they spend there and where they live, basically, and all from mobility data. So what I'm using is the census block groups, which is where people live, the amenities of the points of interest where they visit. And I do this across, again, functional urban areas across the US. And I create these bipartite networks between census block groups and amenities to show how do amenity consumption look like across income groups and other demographics in the US. So some preliminary results from Boston. The first indicator that I look at is the number of amenities that people visited weekly. And this is how many amenities people from a certain neighborhood, census block group, visited in a week, okay? How many gas stations, grocery stores, and pharmacies, and so on. But you see here on the left that the number of amenities visited weekly, when it comes to grocery stores and gas stations, there's a much more diversity in kind of choice, even in pharmacies, whereas in other stuff like liquor stores or hardware stores or florists, people usually go to 1 or 2 in a week. When it comes to public facilities, the schools show a very wide distribution. This is just because this is choice and preferences that has restaurants that people visited. There's Title 1 on the left, on the left is always the low income. On the right, the dark cat is the radius of travel, how long people travel. So what I showed before is basically what exists. And here is what I'm looking at is basically the demand. So not only what exists there, but how people use them on a weekly basis. And what we see is that in these kind of day-to-day amenities, people on average travel somewhere around between 2 kilometers to 5 kilometers, maybe very widely, to reach these kind of day-to-day amenities. But again, it differs when it comes to restaurants and gyms and clubs. And I think, again, this is capturing things that behaviors that people are not only visiting from home, but also from work. But what I'm showing here, that this kind of behavior of how long we travel to an amenity differs across all income groups. So what we find is that people that has lower income has much less ability to travel long and wide for their amenities. And what they do, usually it's because they have a lack of public transportation, and they travel much less, or in the median and also in the minimum and the maximum, to amenities. The only consistent one is around schools, as you can see here in orange on the top left. That is kind of consistent because this is something that is managed by the city itself. Whereas in every other amenity, we see that people that have higher income travel much longer in average to reach their desired amenity. Some of it is because they live in the suburbs and they actually do not have access or easy access to these amenities. And some of them is because they actually use their cars and they can basically choose where they want to go, whereas lower income people rely on public transportation and have less access. So this is kind of where I end. As you can see, there's like a wide range of different metrics to look at how people use their cities. And I hope that someday I can really implement them in data decision